floating and sinking. An object that is partly or completely submerged experiences a greater pressure on its bottom surface than on its top surface. This causes a resultant force upwards. This force is called upthrust. Now let's determine an expression to calculate the upthrust. Figure shows a metal cylinder that is submerged in water. The arrows represent the size of the pressure acting around the cylinder. The pressures exerted on the sides of the cylinder will cancel out. Because the pressure exerted by the water increases with depth, the pressure on the bottom of the cylinder is larger than the pressure acting on the top of the cylinder. Pay attention. You know that these pressures depend on their depth. We can find the total upward pressure on the cylinder exerted by water pressure by simply taking the difference between the pressure on the bottom and the pressure on the top. Let's find the difference between these pressures. Notice that each term in this equation contains the expression density times gravity. So we can simplify this formula by pulling out a common factor of density times gravity. The difference between the depth of the bottom of the cylinder and the depth of the top of the cylinder is just equal to the height of the cylinder. We can relate these pressures to the force by using the definition of pressure. Pressure is force over area, which can be solved for force to get this expression. Here is the interesting part. Since area times height is equal to the volume of a cylinder, we can replace the term area times height with a volume. This formula gives the upthrust on a body submerged in a fluid or liquid. Let's take stock of what we have now. Notice how the upthrust only depends on the density of the fluid in which the object is submerged, the acceleration due to gravity, and the volume of the body. This difference in pressure creates a resultant force upwards called upthrust. Now let's compare the upthrust with the body's weight. To compare the upthrust with the body's weight, we should write the expression for the body's weight in terms of density of the body and its volume. You can see that the difference between upthrust and weight is the density. To upthrust, we use the density of the liquid, and to weight, we use the density of the body. When solid objects are placed in liquid, they will float or sink depending on the density of the solid material compared with the density of liquid. An object floats if the upthrust from a liquid is greater than the object's weight. Look at this figure. if the object is less dense than the liquid, the upthrust is greater than the object's weight, and it will float to the surface. An object sinks if the upthrust from a liquid is lower than the object's weight. If the object has a density greater than the density of the liquid, so it sinks. An object neither sinking nor floating upwards if the upthrust from a liquid is equal to the object's weight. It will stay still. If the object has a density equal to the liquid, the object is fully submerged and it stays still. Example, the weight of a solid cube of side 0.2 meters is 120 newtons. It's put into the tank of water. Determine whether the cube floats or sinks. We have the weight. We should calculate the volume of the cube. Now take the formula and substitute the values. The upthrust is less than weight, so the cube sinks.